Okay, this is video 5 in the test 1 review. Let's go back up to our list of things we were going to talk about. We were going to talk about deriving the basic VO-VI relationship for the two standard canonical models. We looked at the inverting. I'll let you look at the non-inverting. We considered both the infinite gain and then the finite gain, open loop gain cases. Secondly, we applied superposition to solve op-amp circuits. And now we want to look thirdly at determining the input and output equivalent networks, or Thevenin equivalent. Lastly, we'll derive some transfer functions involving op-amps. So let's look at the same circuit that we've been working with, and let's ask the question: if I said, what is the impedance that is seen when looking into this circuit? What is the impedance seen when looking into the circuit? Your response should be, well, looking in from where? Okay, because there are three sources here, and the impedance looking in from any one of those could be different. Let's consider the three cases. Okay, the three cases where now perhaps I'd give you a problem that would just have one source on it. But it could be the 1 volt there, it could be the 2 amp source, or it could be the 3 amp source. So we'll look at the input resistance for each of those. So if we're going to look at the input impedance, or consider the input impedance for the 1 volt source, what we'll first do is we'll delete this one, we'll cross this out, we'll cross this guy out. In fact, what we're going to do is I'll just take these off for the moment, kind of unclutter, declutter. Okay, so we're going to connect right here, and we're going to look in and say, what is the impedance looking in? Now in this case, we might as well just say what the Rn is, because there's nothing but resistors here. Okay, so what do you see? All right, in this case, we actually have a 3 ohm in that's going to ground. So right away, Rn, I'll call this Rn1, 1V. Okay, so this is from the perspective of the 1 volt source, would be equal to 3 ohms. All right, but then there's something in parallel. We can look at, or you can consider all of this here as having basically some equivalent resistance, which is going in parallel with the 3 ohms, right? And we're connecting across there and saying, what is that resistance that you see looking in? Well, it's going to be 3 ohms in parallel with whatever is seen when we look toward the op-amp. Okay. The key here is to remember that if, specifically in this case, if you have the non-inverting input grounded, or even if, say that I had this non-inverting input connected to, say, VB, right? Before you can answer what is the input resistance to the op-amp circuit, you actually have to turn off all of the independent sources except for the one that you are representing, right? In this case, we're representing the 1 volt source, looking in, saying, what do we see? So in any case, whether it was truly wired up as having the non-inverting input grounded, or if it was connected to a voltage source, the first thing you're going to do is turn off that voltage source, which effectively grounds it. So because of that, we recognize that V minus, which is equal to V plus when there's negative feedback, will actually be 0 volts. All right, and that really simplifies things, because now we can see really that what we have is this right here, where this point here has been grounded. And forget about the rest of the op-amp. We basically have 3 ohms in parallel with 1 plus 4 ohms. Okay, so this is just simply 3, 5, or 3 plus 5 ohms, and that's it. Now let's consider the next case, okay, where we're going to, oops, wrong one. We're going to look in from the current source's perspective, and we'll say Rn2, 2 amps. Now when we turn off the 1 volt source, we actually short it. Okay, so we're going to short this, which means that the 3 ohm resistor has no impact. So what do we have? We have Rn 2A amps is going to be equal to, well, right away we see there's a 1 ohm going to ground, right? Then it's going to be in parallel with what's to the right. What's to the right? Well, again, we see that this point here is 0 volts, virtual ground. Right? And that tells us right away that, okay, I don't have to look past that point. It's as if that 4 ohm resistor was grounded. And so I have 1 ohm in parallel with 4 ohms. And that's it. Lastly, let's consider the case for the 3 amp source. All right. Now, if you haven't worked one of these yet, why don't you pause the video and solve for this one, and then start it again, and you can see the answer. All right. So we're going to turn off the 1 volt source, and when we do that, we short here. I've turned off the 2 amp source, which is getting rid of it. And so this is actually the easiest one, although it might initially look different because of just how it's drawn. What you would do is you would kind of define these terminals here. Okay, and say, what do I see when I look between the inverting input and ground? And again, we recognize that this V minus is a virtual ground, right, for the case where AOL is equal to infinity. And so this one, in a sense, is the easiest, but it's also the trickiest, because you might be thinking initially, oh, the input impedance to this one is going to be just the 4 ohms plus the 1 ohms. But you have to recognize that the 4 ohms plus the 1 ohms is in parallel or connected between 2 nodes. One of those nodes is actually grounded right here. The other one is a virtual ground. But there's 0 volts across those resistors, so no current flows. That's the trick. There's 0 volts across those resistors. So like to answer this question, you'd say, what is the voltage on either side of this resistor branch? On the left side, it's 0. On the right side, it's a virtual ground, so it's 0. Therefore, there's no voltage across these resistors. If there's no voltage across these resistors, there is no current that flows. And if there's no current that flows, that might as well be an open circuit. So really what we have here is a simplified circuit that looks like this. And we're asking the question, what is the voltage between the inverting input and ground? And the answer to that is that Rn 3 amps is equal to 0 ohms, because the inverting input is at a virtual ground. So regardless of what kind of current you put in at that node, that virtual ground remains at 0. That's as if you had a short between there and ground.